Welcome back to Chapter 5, and this is Lesson 5.5a, Identifying Similar Figures. Similar figures means that the figures have the same shape, but not necessarily the same size. For example, there can be two squares. They are going to have the same shape, but not necessarily the same size. The same thing can be true for two rectangles or two triangles. They can have the same shape, for example, one equilateral triangle, but it will not necessarily be the same size. Maybe the lengths of the sides are going to be 3 in one equilateral triangle, but they're going to be 9 in another. The two triangles will be similar. One of the things we need to do here is a key concept of setting up a ratio of the lengths of corresponding sides, and they have to be proportional. If we can do that, then we can prove, or we're well on our way anyway, to prove that the two figures are similar. We also need to deal with corresponding angles, and they have to have equal measures. We call them congruent angles if they have equal measures. We don't say they're equal, we say they're congruent. We do use a symbol, which is kind of like part of an approximation sign, and for geometry this means similar to. If we look at our first example here, two polygons are similar if, and notice that both things have to happen here because of this word and. The lengths of the corresponding sides have to form a proportion, and we have to make sure that our corresponding angles are congruent. In this first example, we're going to look at which rectangle is actually similar to the shaded rectangle, which is in green on my lesson. Now, the one thing you've got to be very cautious about is that you absolutely cannot set up the ratio in the same polygon. For example, I'm going to set up 4 over 5. I'm not going to set up 4 over 6, and I'll show you more about that. One good way to make sure that you're setting up ratios in the right way also is to make sure that all of your polygons have the same orientation. Now, the shaded one has the smallest, shortest side vertical, the longest side horizontal. And that's true for all 3 of the other rectangles, A, B, and C. Shortest side is vertical, longest side is horizontal. So what I'm going to do here is check out each rectangle. I'm going to start with A. Again, I need to make corresponding sides, so I'm not going to go 4 to 6. I'm going to go 4 to 5, because the 4 and the 5 are corresponding. They're both vertical, and they're both the shortest sides of the rectangle. Is that going to be equal to 6 over 8? Now I'm going to reduce, and because I do not need to use cross products, I'm going to do it down below here. And I'm going to get 3 over 4, and I'm going to say no, because obviously 4/5 is not equal to 3/4. So the shaded rectangle is not similar to A. Let's look at B. Here again, I have to be careful. I'm going to correspond, I have to set it up that 4 corresponds to 8, and 6 is going to correspond with 12. Now, if I can get those two fractions to be equal, then I know that they're proportional. Well, 1/2 equals 1/2, so yes, rectangle B and the shaded rectangle are proportional. Let's see if you can do C. All right, 4 corresponds to 6. Is that going to be the same proportion as 6 corresponding to 9? Well, 4 over 6 reduces to 2/3. That's 6 over 9 also reduces to 2/3. So yes, those two rectangles are in fact proportional. And of course, we know that rectangles, all the angles are 90 degrees, so our angles are going to be congruent as well. In the second example, they're asking me if rectangle EFGH on the left is going to be similar to rectangle PQRS on the right. Now, first of all, these are both rectangles, so I know the angles are congruent because by definition a rectangle has 90-degree angles. The thing is, and this in rectangle EFGH, notice that the short side is horizontal, but in PQRS the short side is vertical. So to set up the correspondence, what I need to do is kind of rotate this particular rectangle. And it can be kind of hard to do. I can do it here very easily using the smartboard, but you kind of need to do that mentally. Okay, so I'm looking for short side to short side. So that means 18 to 36. And then is that equal to long side of 27 over long side of 54? Now notice that I did not set it up as 18 over 27. Rectangle EFGH is in the numerator position. Rectangle PQRS is in the denominator position. And I have to make very sure I do that. One rectangle is denominator, the other one is numerator. Here again, I can reduce. This is 1/2. 27 over 54 also is 1/2. So yes, they are proportional or similar. This time, I'm going to do a little bit something different. I'm going to figure out the scale. If they are similar, what is the scale? I need to take two corresponding sides that I know both of the measures for, and that would be 8 and the 24. So 8 over 24. To find the scale, I want to reduce the top number to 1. 8 divided by 8 is 1, 24 divided by 8 is 3. You always want your numerator to be 1 whenever you want to scale. In question B, it says which angle is going to be congruent to angle XYZ. Well, XYZ is this angle right here, and it's pretty apparent that it has to be congruent to that angle. Now here's where I've got to be careful. X actually corresponds to R. Because if I flip this XYZ over to my right, the X is going to land in a similar position to R. Y is going to be corresponding to Y, because there's only one of it, and Z has to be corresponding with P. When I work with C, I need to complete the correspondence. ZY, which is the long leg of the first triangle, and PY, which is the long leg of the second triangle. And then I'm going to compare it to the short side. ZX is to the short side, and it's going to be RP. What is N? What is the length of the unknown side? Now this is kind of going to precursor what I'm going to do in the next lesson, in a following lesson. I know that I have 8 to 24. I know that. The 6 corresponds with the N. Now again, because I'm going to cross product this one, I'm going to reduce this to 1/3. And now I can cross product. 1 times N is N, and 3 times 6 is 18. And don't forget your label of feet. And that concludes lesson 5.5a.